Okay. All right. So the recording has started, folks. So this meeting is being recorded now. And by continuing to be in this meeting, you are consenting to be recorded. So good evening, Brian and Tori. Welcome to our webinar number 2. And actually, webinar for module 1, although it's webinar number 2, is from a course perspective, but this is for module 1. And as soon as my screen starts working, I can go to my next. Okay, alrighty. So to my next slide here on the etiquettes, and we said we really don't have to go through this all. You know the drill, and being a small crowd here, absolutely feel free to ask questions anytime. Only thing I would say is just limit any distractions around you. If you have to speak or if there's things going on around you, please mute your microphone. You can use your video while you're talking, absolutely not an issue. As I said, we're just a small crowd here, so we don't have to worry about all that. And I'll try to keep this within an hour, as what we did with the course introduction webinar. We'll try to kind of keep this to an hour, but in case we go a little bit over, trust me, I will try to cap it at 10 minutes or 15 minutes after the hour. I will cap it, okay? But if you have to go, let me know that you need to go after an hour, okay? So with that, let's move on to agenda for today. We'll talk about big data and Hadoop ecosystem. Once again, my goal here or any webinar is never going to repeat anything that you would have learned, but try to validate that. I'll try to add some more color to what you would have done, supplement the information that you have received, you've gone through during that or while working on that module. Okay, so that's what we are going to go through very briefly, go over that. And then we'll talk about assignment 1, which is very important. Just want to make sure I address all your questions. And then we'll go on to seeing any other questions that you may have in general. Okay. So just a week 1 in retrospective, we'll kind of just go through how your week 1 has been. I'll tell you that from what I've seen from your discussion posting, they were timely and with quality. Many of you embraced the spirit of engagement and participation by reviewing your classmates' posting, asking good questions, responding to your classmates, responding to my questions, and all that. So I saw a lot of good participation engagement. So keep it up, I think the entire class, and I think if there are more than 90% of you kind of done a fantastic job. In terms of participation, in terms of the quality of discussion postings that you've had. And I'll still go over with what we could do better. I mean, I'm sure there could be, you could do better in discussions and grab those maximum points. Trust me, these are the biggest, and you saw that, right? Like in the course introduction webinar, that 320 points for discussions. So do not let it go. And I'll kind of keep repeating that, guys, because I can't tell you that this is the easiest point. And you'll tell me maybe at the end of the course, those were the easy points that you could grab. Besides, of course, all others, and there are others to kind of also grab. But as I said, 320 is a lot of points there for your 4 discussions that you have to go through. And plus, take advantage of these webinars, right? We're here. Let's gather. Let's come up and talk about the module that you're going through and see how I can supplement that information, ask some good questions, and take this, as I said, it's not just about just reading material, about assignments. It's about, as much as you can gather or gain, module after module. Okay, so, you can be here or, watch the recordings. I understand that everybody has lots going on and with other courses and family and so on and so forth, and I completely understand, but watch the recordings if you cannot make it to the webinar. Just one more in retrospective, one of your classmates did actually bring it to my attention. There was one quiz question. Not everybody got this question. But some of you did get this question for the quiz, where it was, the question was the additional V's that help us understand big data from business perspective are, so there were all three: value, variability, veracity, and there was all of the above, there was none of the above. And the answer was all of the above. But the trick and the main problem was, if you say all of the above, none of the above is also considered all of the above, right? So what would you really check? Now, I think a couple of you I saw just checked everything and you still got a point. But then, some people, I think there were a couple of them who got really tricked by this question, did not know what to really check on. And so I went into each of your quiz submissions. If you had this question, you attempted it, you got it wrong, because, and although you had the right answer, I have, given points to you. I have updated it myself. So your grade has been corrected. A couple of you may have seen their grade all of a sudden going from 90% in the quiz to 100%, and that's because of this. Okay, so I just wanted to let you know, and we'll be correcting in the future classroom. So I do not want to correct it midway while everybody's going through the quiz. So we'll let it go. But as I said, I was very much watchful of each of your attempts. Okay, so with that, the discussions, as I said, no late submission. You must have figured it out, that there was an end date for the submission, and that's not going to change for any of the discussions. They will close on the end of the week on Tuesday night, 11:59. No more postings, no more response backs, nothing could be done. It gets locked, right? So you know that. Make your initial discussion posting as soon as possible, preferably earlier in the week, as much as you can, if it's a Saturday or a Sunday, so you get your responses back. Please, you may not want to wait until the last day. And I'll tell you the reason why. You'll get to know the reason why I'm saying do not wait until the last day, the last evening. Because A, you have to also comment on at least two of your classmates' initial postings. And B, if you post it late, and let's say, you need your response back, you need to hear from someone about your posting, but if you do not get it back, then if nobody happens to respond to your message, which could be at the last minute or the last evening or last night or an hour before, the submission closing, then if this happens and the class week is almost over, then you need to respond with additional comments to your own initial post. So it is not just about putting something on the discussion and getting away with it. Trust me, you will not be able to get full points for your discussion posting. If you just post it, you need to address to or respond to at least two of your classmates. And if nobody is going to be able to respond to yours because yours just stood there and yours was posted at the last minute or the last day, then you have to respond to your own with some modification, right? I'm not saying ask a question to yourself. That's not possible, but take a stab at your own, throw the dart at your own, posting, and come up with some modification to your posting, right? Enhance your posting. Okay, so this is very important, guys. This is what is going to get you the full points in discussions, the maximum. If you want to go for maximum, then you'll need to follow this format for the discussions. Okay, any questions before I move on? Any questions on week one retrospect? Anything that you found on week one that you want to ask about? Comment before I go further.
Not for me.
Okay. All right. I'll take that as no. Okay. Alrighty. So let's talk about you read a lot of material about big data, right? So let's validate these statements. And I want both Brian and Tori to kind of participate as much as possible and help validate these statements. And once again, I'm not going to, this is not to put you on the spot. This is to kind of take this further, take your learning further and see if how we can take this and talk a little more about big data. So let's validate these statements, right? The first one is anything that I'm unable to store on my laptop is big data. Do you guys agree with this statement or no? Yes or no? And why?
Well, I guess it might depend on your laptop capabilities. I would say the answer to that is no.
Okay. Tori, do you have the right answer? I'm sorry, do you have the same answer as Brian, or do you have a different answer?
I do. I don't feel like that it's really quantified very well since laptops are different.
Okay. So would you agree to this statement? Would you say yes, no, or maybe?
Oh, I'm sorry. I agree with Brian. So
Oh, okay.
I would
Okay.
say
Oh,
sorry.
okay. Okay. Wonderful. Okay. Very good. Okay. I understand that. All right. So hold on to your thought. Okay. We'll come back to these statements again, but hold on to your thought of what you just mentioned. Unstructured or text data is big data. What do you guys think about this statement?
It can be.
Yeah,
Okay.
I agree. I mean, it meets the variety prong for sure, but that's just one prong.
Okay. Hold on to this thought again. Well, thank you for your response. Size of data has increased due to pictures and videos. So our small data has become big data. What do you guys think about this statement?
I don't think it's necessarily true. Um, I mean, I don't know. Yeah, I would say I don't agree with that.
Okay. How about you, Brian? What do you think?
Uh, on the fence, but I guess I would say I don't agree with it.
Okay. Okay. All right. Well, let's hold on to what you guys said, and thank you for your honest response and opinion on each of these statements. And we'll come back to this as I promised. I want to just go through a couple of things real quick, and I think Tori just alluded to that, to some of it, right? What are the I think you've heard about the 3 V's of big data, and those are important, right? What are the different characteristics that really make a data as big data? One of the, and I put the fourth one because that's equally important. And I know there are 5 V's, there are 7 V's, there are 9 V's now. So, but I think this is at a minimum, I would want to see at least 3 or 4 of the V's, really kind of that, if any of your data really has these characteristics, then they can certainly be, you can be certain that it's a big data. One is the volume, right? The huge data set. Like when you're talking about volume, we are talking of terabytes and petabytes, and and even anything larger than that. That's the kind of volume we're thinking about, right? So, and yeah, Tori, you were right. Like, what your laptop could be, it's subjective, right? You could have somebody could have a laptop, a Chromebook with 100 gig, and others, somebody could have that 1 terabyte, 2 terabytes worth of for laptop. So anything bigger than your laptop, well, it depends. These days you'll get laptops 2 terabytes or even more, I don't know. But yeah, so with that kind of a volume, well, there's it's relative, but what the type of volume you're looking at is huge. You're talking about petabytes of data, and it's not just the volume, it's also the other characteristic that you're looking at is velocity, right? How quickly, what's the speed of data? How quickly is data coming at you, right? So what's that flow like? What kind of, what kind of a speed that your data has? And and you've seen data coming at in so many different applications. Like if you think about the Facebooks, the Instagrams, the and many other applications that are out there that just generate tons and tons of data every second, and the data comes in so fast. There are millions of users of all these different applications, and and the social media applications especially, and millions of users who use it. So think about all the data that is generated, not just the volume, but the speed of the data. And then the next is the variety of data, right? Your data is not just unstructured, or not just structured, it's unstructured data. There's pictures, there's videos, there's different kind of, there's a text data, there's numerical data, all sorts of data that is coming at you, and that could be coming at a different format, and different data sources as well. There are so many different sources. Now you're trying to pull in data and try to make sense out of it. So with that comes in, with veracity, right? Because now, because of various levels of data and different data sources, it comes along with uncertainty, right? It comes with unreliability. And if it also, all of these different characteristics that you can see in your data that you are having or seeing in front of you, it could be labeled as big data, right? So now going back, and before we go back, just I got one more slide. So to kind of show the different comparison, right, about what is small data, large data, and a big data. A small data, well, it could be in megabytes. Some of the examples are like sales records, customer databases, and for small and medium-sized companies, you have hundreds and thousands of records. This could be all stored in your personal computer. It could be, processed via Excel. You could use R, or you can use some basic statistic software. You can do simple statistics on it. So yeah, that's pretty much, if you're able to manage things, and you can process things with using some of the simpler tools, some of those popular tools. It's kind of a small data, right? It's manageable data. Then you got the large, company databases, which large, huge customer databases, huge records, huge telephone records, huge, all of that is, there's gigabytes and terabytes of data. There's millions of records, millions of customers. And that's, it could be mostly structured data, because it's kind of all data that's coming into your database, and you're using different, really large machines, maybe on-prem servers, or maybe some relational database systems. You're using cloud, maybe even using cloud these days, right? But they're all really, they could still be large data, because once again, still manageable with some enterprise level tools, right? You may not be able to use your own laptop or your own version, your desktop R or desktop Python. Maybe you'll need something more than that, right? And you need an enterprise version of these tools, or enterprise version of your hardware, to really manage this data. But it's good to still large data, because it's still manageable. Then comes the data that is really coming at high speed. The volume is so high, we are talking about terabytes and petabytes of data. And we're talking about, all different varieties of data, all this social media, the mobile, the multimedia, videos and audios, and all those audio clips and so on, all the machine sensor data that's being generated every second, all of that, and millions of records. And there could be even unstructured data as well, as we just mentioned. It's a mix of all different kinds of data, which you will find it in different large data centers managing it, or being on the cloud, or you're using all this, not so typical databases like the NoSQL databases, or you using Hadoop. It's all distributed across multiple different centers. That's your typical big data, right? So now let's go back to, validating the statements. Anything that I'm unable to store on my laptop is a big data. Well, it may not be true, right? You may be able to take it from your own big data, and you can and your laptop, what is not able to store, because your laptop is maybe 100 gig, but I may be able to store it in another laptop with 200 gigs, right? Or maybe where I have got 2 terabytes of memory there. So still may not be big data, right? We don't know. We don't know the size is not mentioned here. So we don't know exactly, but it's quite likely that the answer is no, which is true. So I think you both were right there. Unstructured or text data is big data. Well, may or may not be. Once again, we don't know the volume. What volume are we talking about, right? Is it just unstructured data? Could be just one Word document, right? Or one picture, or multiple pictures put together, or maybe multiple documents. Like you may have 5 documents. Is that a big data? May not be a big data, right? Once again, we don't know what we're talking about. What's the size here? It's not very clear. So may or may not be again, but once again, your answers were true and responses were right. So the last one here, size of data is increased due to pictures. Yes, it has increased, but can it be labeled as big data? Maybe not, right? We could be talking about all the pictures and videos on your laptop, right? They're not been changed. They're not coming in at a high speed. You are taking pictures maybe once every 2 days, maybe once, maybe on a daily basis. Still, it's not coming at a large velocity. It's not petabytes and terabytes of data. It is still manageable within your laptop, or even sometimes even in your phone, right? In your iPhone or Android phones. So it's still not a large data. Maybe it still could be considered as maybe a small data, or max. I would say it would large, but no, large would still large, right? Really, really large. So it still would be, just data, not really big data, right? So any questions on what we went through so far? Are you guys with me and tracking with me so far?
Yes.
Okay, very good.
Yes.
So one of the things I want to kind of talk about also, and you would want to take away from this session, is also an understanding of why did we learn about big data and Hadoop, right, during this week or during this module? Why are we doing that? I'm sure many of you would have, as I said in earlier in course introduction webinar also, that you may have read about some of the stuff that you did, maybe in previous courses, in other courses, I'm sure. And you could have beaten this topic to death about, what is big data, right? Maybe you would have even learned about Hadoop, but why are we doing that here? And I want to kind of, at the end of this session, I want you to kind of have that appreciation of why you did this, right? And is this really important? Or should you even go back to reading some of the material that you may have just, skimmed through or may have missed it in some way? And that's what the next few slides is going to address. Why what you learned or what you're learning during this module is so important. Besides just setting the base for the weeks to come and the modules to come in this course, there is a purpose that that we have this particular topic for your first module. So the first thing coming up is some of the use cases, right? You read about the use cases. You had a whole discussion on some use cases, which is wonderful. I mean, some of those use cases, you gave your own opinion, you came up with some great ideas, you kind of interacted with your peers, your classmates on these use cases. But there are some very, very interesting other use cases as well, very recent use cases that I wanted to bring it to your attention. And first and foremost, and this is something you may have also heard about, something called smart recruitment, right? The recruitment process is becoming much more smarter than what it was in the past, right? In the past, yep, you used to have all those, the hard copies resumes, and used to go around and just give out those hard copy resumes to your recruiters or to your friends or to your family looking for jobs, right? It came down to sending out PDFs and sending out those Word documents. And then it came down to, okay, you kind of still do that and you still keep doing that. But what has also happened, I mean, these companies who started to get soft copies of your resumes, well, some companies kind of added their flavor of saying, okay, let's look at some of the keywords. Let's extract those keywords, right? Let's find out who is our best candidates. We got like 100, resumes. So some hired more people to scan through those resumes to make those perfect hiring decisions. Some made some homebrew tool at saying, okay, let's write a program to kind of parse through this quickly and give us an idea as to who's going to be a best candidate. Yes, so things evolved. Now it has reached a point where they want to know this candidate 360-degree view of the candidate. And how do they do that? And you know this for a fact that people look at your Facebook profile, your Instagram profiles, your social media footprint is being viewed by these recruiters, right? And you may have heard this, right? When you're looking for a job, people say, oh, please be careful what you're posting on the internet, because what you post out there could be viewed by someone that you don't want it to be viewed, and you could be in trouble, right? So yeah, because so this whole process of recruitment is not just about what you have on your resume, it's also about what you've been doing in the past, what kind of a footprint you have on the internet about yourself. And that's what is going to give them an idea of what kind of a person you are, right? It's beyond what you have on your resume, beyond your academic accomplishments. And they want to know you. And if they want to know you, they could know that by there's lots of data out there. Facebook and all these kind of social media platforms sell this data in some way or the other, or share this data in some way or the other, right? And if you have not been really closely following the privacy policies or opting in or opting out, you could be in trouble, because a lot of this data gets shared across and or gets sold to certain companies or to entities. And but in any case, so that's what one of the recent big data use cases is getting into this kind of a smarter recruitment. And there's lots and lots of data that is gathered about a candidate, and this multiplied by the number of candidates that apply, and that gets scanned by these companies. The other big data use case that I want to bring it to attention is this optimized supply chain and logistics management. Think about all the things with the use of GPS and telemetry data that is being used today to, like, for example, to get the most optimal delivery routes, right? Like many of these trucks, for FedEx trucks or Amazon trucks and all these trucks that are running around in our neighborhood, they are, there's a method to the madness. They're just not just taking some packages and saying, okay, you go to city, you go to Virginia and do this, you go to Maryland, or you go to this town. There's much more to that. There's a whole kind of as a process to find out what is going to be the best route for the truck. One of the reasons why sometimes the shipment comes to you at such a faster rate than what you would have expected. Some comes in at such a slow rate than what you would have expected. And sometimes you see there's a package that is delivered across the street to one of your neighbors across the street, but you are waiting for your packet and you still do not get that. And it is still from the Amazon, and you know that it is out for delivery, but that truck is not delivering it. There's another truck that is coming on the side of your street, or where on the side of your house, and delivering it, right? You may have noticed or seen this before. So what I'm trying to say is that there are some and there's a reason for all this, because they want to find out the best routes for their trucks that is going to be able to able to maximize the deliveries with minimizing the cost that is going to be the operational cost that these companies will incur. So that's where this tons and tons of data that is being gathered by these telemetry and GPS data, and they kind of bring it all together to see, okay, what are we, and all these delivery locations, the customer information, the driver information, the coordinates that they need to be covering today, all that kind of put into play into a model that is going to give them the best optimal routes. Then in other cases, there's like something called Amazon's anticipatory shipping program, which is not I wouldn't say that they're really being, used, or Amazon is very high on it, but there's something that's currently being worked and they still want to kind of get this going, which is no understanding what a person may need. And before they even think about, ordering it, it's sent and supplied and sent and delivered to them, right? It's kind of anticipating what is Linash going to need? What is Brian going to need? What is Tori going to need tomorrow? And and why do we need for Tori or Brian to take any action? Why can't we take action on their behalf and send something to them which they would want? Now, many issues, right? You could say, oh my God, this is terrible because I may not want what they're sending me. I may want to stop that, what they have been using for the last, 12 months or to 12 years I've been using, I want to stop it, right? But still, these guys would not stop it. They would keep sending me. Those are some privacy issues as well, which could come into play here, right? Because you're trying to, once again, make use of certain information, maybe using your credit card to kind of bill you for something and sending it out to you for something that you may not have authorized anyone to do it, right? So all those kind of issues, they're kind of still working this out, but it's once again, these are all coming up based on having such a great knowledge, having this huge view of each of us, right? What did Brian order during the last, maybe a year or 5 years or 10 years that he could need now going forward, or maybe he will need tomorrow or next month, right? Coming up with that kind of a analysis is huge, and that analysis is possible today because the companies are storing this kind of data. They have the ability to keep all this data, which yesterday, and when I say yesterday, I mean years back, they did not have that ability, right? They did not care what Linash or Brian or Tori kind of order, or Yelena ordered, years back. To hell with it, we are done. We purged that data. We don't know. We don't even want to know, because the companies were more reactive. They would react based on what we are going to order. They were not proactively or doing anything. They were not proactive in saying, okay, we'll send something over to Linash because Linash is going to need this tomorrow. Oh, okay, well, Tori is going to need this thing tomorrow, so let me send this over to her. No, they want to kind of be proactive. So all this data, all this ability to manage and process data, big data, has really helped these companies. And one of the, again, use cases. The other use case is about the in-store experience, right? Some of these, and this is like just a few months back, I'd seen a demo of one of the use case of the big data and how they kind of created like not a device, but an application whereby you are, very getting closer to bank or a particular store or a large department before you enter, like while you're entering it, and before you really enter, they would know that you are approaching the store, you are approaching the bank, so that and they want to make this really personable. They want to welcome you. They want to have somebody from their their store or from their bank to go and welcome you and then kind of give you that personal kind of real good experience of being welcomed in that store or the bank. So they combining all these, geolocations and in-store cameras and all of that, and all this, using all this face detection technology, and making and seeing what your location is using your mobile phone, and all of that, bringing it all together and kind of knowing, okay, Brian is approaching his bank and he is right at the door. Okay, before he enters there, we want to be there to welcome him, right? How cool would that be, right? How would Brian feel when somebody is at the door welcoming him, right? Knowing his name, even though this person may not have known him, right? This person would, just because he is a customer of this bank or he's a customer of this store, somebody is welcoming him. Or you're entering a big department store only to find out there's there's a ticker there, or something flashing there welcoming you, or there's an announcement made, hey, welcome Tori, welcome to to our store, if you need help, we are here, right? Something along those lines. How would Tori feel, right? What kind of an experience would she have when you are welcomed this way, right? You feel like, wow, this is my store, this is my bank, okay? And maybe that you would want to do more business with these kind of the stores and banks. And that's what is being used, because it's using a lot of your mobile data, the geolocations, your face detection, all of that. Of course, you have to register in order to kind of, be that person who they can really welcome. But this is something, and they're trying to enhance your in-store experience. Okay. So, and the last one is about this use case about the 360-degree citizens view. A lot of government agencies are working to connect your telemetry, your health, your family connections, your registration data, such as social security, your passport, your bank, your real estate, all that data put together. What a huge kind of a data set that your government agencies would have. They would have a complete view of the entire citizen, but work in progress, right? There's so many things. You could throw darts at this right away, right? There's so many privacy issues here. Why should someone know about my health? Why should someone know about my bank? Why should the government know about my, real estate deals or whatever, right? And of course, taxes, IRS is different and all that. But what I'm trying to say is, if somebody's going to hold this data, my God, it's a huge, it's like a gold mine, right? They're creating, and they have to make sure that their citizens are going to be safe, because you don't want this data ever to fall in wrong hands, right? And plus, the citizens should be willing to share this data with government agencies, right? The agencies that are collecting this information. So there is there's kind of some work in progress here, and we don't know how far this would go. But there are government agencies of many different and government here, not just in United States, but even outside. You'll see a lot of governments are trying to do something like this, right? um, and of course, we are at the forefront of this. There was, I know, in India a few years back, which is like more than a billion population, billion people in India. And what we had heard that time was they had already fingerprinted more than 900 million people were fingerprinted. It's so huge, having 900 million plus people fingerprinted, and this is few years back. I don't know if they've completed that whole project, if they've got the fingerprints of all their citizens. I don't know. But that was huge. It was like saying, wow, it's again another gold mine, that through fingerprinting, you could be able to do a lot in crime solving, and in trying to know your citizen or whatever that is. But yeah, so many different use cases that and this and by just managing big data, that these companies have been able to leverage and use it in so many different ways, right? Okay, so let me pause and see if there's any questions from you guys. What do you guys think about any of these use cases? Brian, Tori, are you guys still with me? Did I lose you?
Yeah, I'm here.
Still here. Uh, was this too long? But what do you guys think about these use cases? Any questions on them?
I don't have any questions. As like we're going through them,
Okay.
I think there are a lot of opportunities, obviously, but I think that people tend to be sort of distrustful of, I think partly because all of these efforts are very complicated, and maybe difficult for the layperson to understand.
Yeah, yeah.
So, that there's some that might be a factor.
Yeah, yeah. No, you're right. It's distrustful, complex. Um, and would people really trust you with all this data, right? With you, and plus you're building a gold mine, right? And if you're building a gold mine, you want to make sure that you have, perfect security for making sure this doesn't fall in wrong hands. That's my biggest fear. If someone tells me that they need all this information that's up on this slide here, well, I want to make sure this data does not fall in wrong hands ever, right?
Yeah.
And somebody would have to give me that confidence, right? Whether it's a federal agency or whether it's another kind of agency that is supposed to get all this data. Well, that would be my biggest concern is, are you going to be able to hold this and not ever let this in wrong hands? That's
But boy, we sure hear about a lot of breaches. That was the first thing that hit me in all of these cases, is the security aspect of it.
Yeah, you're right. So you're so right, Brian. I mean, the amount of breaches that happen and keep happening, and what people are doing, what these breaches, and half the breaches, trust me, does not even get published ever. So you've heard some of the companies even hiding some of those breaches, and only to find out after a few years that this breach has happened or that had happened, or a year back, or you get a letter in the mail 6 months back, there was a breach that happened. Why are you telling me 6 months later that there was a breach? And I'm sure you must have also kind of got similar letters or notes, or you may have heard in the news that some of the breaches happened months ago, and yet people are, Yahoo accounts were all, they were stolen, or there were information being shared. And this happened like a long time back. I said, wow. But anyway, so yeah, you're right, Brian. It's a big concern with all the breaches. And that's the reason why these companies are not able to, especially for this one here, or some of the other use cases too, where work is still in progress and they're not being able to make a big headway and complete this, right? And this is one of the reasons. I hope the whole cybersecurity sector really does well and is able to kind of, put up some kind of a shield around, or they kind of come up with different techniques, you know um, or technologies that was going to kind of hold this data together without and safeguard this very well. Good. Anyway, okay, so now good comments there. Thank you. So the next few slides, and I'm not going to go through this illustration. I just found this illustration by Manish, and I really loved it. This is about, and there are like 4 slides of this illustration here, which shows the handshake or the interaction among the client, the name node, and the data nodes. So it's kind of just showing what Hadoop is all about, right? What are these data nodes? What are these name nodes? What happens when a file needs to be stored on a Hadoop or a Hadoop framework, right? Or when you need to read file from a Hadoop framework. So and I'll let you kind of go through this as when you get this deck. You can just go over that, but it's pretty cool. I think after going over this illustration, you don't have to really remember all this, the articles or things that you would have read about name node and data node and try to remember, oh, what is what. I think by looking at these pictures, you'll be able to remember it even in a much easier way. At least when I go through this, I say, oh, okay, this is much better. I wish instead of reading through all that documentation, I could have just, gone through this few illustration or few slides of illustration that was there. It was a nice infographic. I loved it. And that's the reason why I'm sharing with you guys. Okay. So take a look at it and hope this kind of helps you. Okay. So not really going over them. So the last illustration I have about the map reduce, right? So the map reduce, this illustration shows what map reduce is, the process of like mapping, like when you are doing the map reduce, what does map reduce do? What does that program does? Like if you're like counting a certain, words or certain, things or elements that you want to really count or find out how many are there or what is there, then what it really does, it goes through first pass is about mapping what you're really looking for in each of your files, in each of your locations. Then those pieces get then shuffled around, and then in the reduce phase, it looks at only those parts that you're looking for, the same parts. The similar parts are brought together, and let's say if it is the names, if the name, and you would see that in your assignment one, how any like multiple files and what you're trying to search through it scans through those different files at different locations to come up with the answer there. So again, another good illustration of what a map reduce is. Okay. And finally, just wanted to quickly, take you through the different implementations of Hadoop, right? You'd think that Hadoop, well, it's been a couple of decades now. Hadoop has been around, and maybe it's there are now newer technology. It has evolved so much. There are newer technologies like Spark, and who's really using Hadoop? And that's the reason why I wanted to kind of bring you back to and bring you and show you, take you through some of these implementations here. Like, for example, on this slide, you see this implement, like British Telecom uses a Cloudera-based Hadoop implementation for their engineer callouts, right? For getting to know about their customer, about their about their engineers, and let the customer knows where their engineer is, who's going to be working for them or working on their ticket. But in all, this whole experience, the whole, after implementing Hadoop, the return on investment was anywhere between 200 and 250% within 1 year of the deployment, because they were able to gather all that data and make it, use it for a good purpose, both for their engineers internally as well as for their customers. So it's again, British Telecom has this implementation of Hadoop for quite some time. Then another huge implementation of Hadoop is deployed by CERN, the Large Hadron Collider in Switzerland. And you would probably know this, one of the largest and the most powerful machines in the world. And tons of data gets generated every second. And they're running this and they're storing and saving this data and doing all sorts of analysis on this data using a Hadoop cluster. That's how powerful Hadoop is, right? Then Western Union is also using a Hadoop-based data analytics. It's using Hadoop-based data analytics platform, which they kind of got it from Cloudera back in 2014 to provide a personalized experience for their customers. So it's again another powerful implementation and used by a very powerful and popular company like Western Union. Yahoo, right? Yahoo is another one which uses the Splunk's Hadoop tool called Hunk. Splunk is, by the way, one of the tools that is used for a lot of, either for performance detection, performance analysis, or for security purposes. And so they have got a Hadoop tool called Hunk, which has been used by Yahoo since 2015. So all sorts of different implementations, different companies are using, multiple companies are using Hadoop here. So kind of trying to, I'm trying to, I'm just coming to an end for, why we learned what we learned during this week one and in this particular module. And one more aspect before we kind of close this topic here. But, if you go to indeed.com, look at the Hadoop jobs, in United States, you'll find that, and this was done like not too long ago, there were like more than 14,000 jobs which required some knowledge, some experience of Hadoop. And if you just narrow this down to even entry level, there were more than 1,200 jobs, 1,200 jobs for Hadoop. So one of the reasons why we're learning what we're learning now, it's important, right? Yes, things have evolved. Yes, there's Spark, which you're going to learn here. There's Spark-based platform. There's Hadoop with Spark implementation. You would see all of that. Yet companies today want you to have some knowledge of Hadoop, some knowledge of and a very good solid knowledge of what big data is, how you're going to identify big data. So this is the reason why we wanted you to kind of go through and gain this knowledge so that we're all kind of level set. You have a perfect and a strong foundation to kind of move on into other modules within this course, okay? And also for building a strong resume for you, right? Because this is important, guys, okay? So and to kind of practice what you really need to practice on, there's I just wanted to also leave you with a nice source for different kinds of data sets that you would want to practice in future, right? You kind of have got one of the assignments option is to make use of a Hadoop cluster and make use of a data set that is given, right? You can probably use, you can just try to do something else more than just what is required in assignment. You could probably do with different things on that Hadoop cluster. Maybe have your own data set being being created or being used or being worked upon on those Hadoop clusters, or for other things that you will see within this course. But just wanted to have you kind of bookmark this to kind of get hands-on to different kinds of data sets for your practice. And lastly, the Hadoop clusters, right? So you will learn about EMR, Elastic MapReduce, which is the Hadoop with a Spark implementation in AWS. So you'll be learning about, and you'll be working a lot on AWS Lab. In Azure, there's something called HD Insight. It's again on Hadoop implementation. Google Computing Platform as Dataproc. So these are all the different services that are available, components that are available in each of these, very popular cloud platforms, whereby, just with, with a simple, configuration of these, and they're very easy to, get started. Not much is really required for you to kind of get, each of these or make use of these services or make use of these components or start a Hadoop cluster in any of these platforms. Very, very simple and easy. They've made it really easy for folks to kind of get, which in few years back, it wasn't, right? So once again, just kind of giving you some idea as to what where Hadoop clusters are and on the cloud environment. So just some food for thought, how would you take your learning about Hadoop ecosystem forward from now? Just think about it. What is your plan to practice the knowledge and skills you have learned during this week? And have you researched areas to find big data sets for practicing your skills? And if not, I kind of gave you one resource, but you can get some multiple resources here, okay? So before I move on to kind of just discussing a bit on the assignments, any questions? And was this helpful, guys? Was this really helpful? I need that feedback as well from you both, especially Brian and Tori, that you're here. Was this helpful?
Yeah, it's been helpful for me. I am going to see if I can find that infographic because it looks really good.
Okay.
I'm gonna see if I can
Sure, it's good. Yeah, it will be there as part of the deck, so you can certainly grab it from here.
Okay.
But yeah, there's I would have listed the source as well, so you can check that out there as well. But thank you, Tori. Brian, and any other feedback you have?
Yes, I found it helpful, and I enjoy your reinforcement videos all the time. I think it's important and it's helpful.
Okay, thank you so much. I appreciate and thank you for the vote of confidence, guys. Truly appreciate it. Just want to make sure that this is the best use of your time. And I understand this is late evening for you and others as well who could be watching this recording pretty late at night, right? So, okay, so I'll kind of jump right into the assignment. So assignment one, as I mentioned, it's the only assignment where you get a choice to do one or the other. So you can either access the Hadoop cluster and MapReduce, not really a very complex exercise, but trust me, if I were you, I would want to kind of do this because it's getting hands-on to a Hadoop cluster and trying out and running a MapReduce program on it. Nothing like it. It's getting your feet wet, right? Getting to know what it is, and which it may not be really rocket science at all, but trust me. And so one of your classmates already tried it. She found it very easy, very helpful, and she got it done. So I think this could be an easier way out. But if not, that's okay. You can still, if that's not what you really want to do, you have an option to go with and write a big data research paper. Um, and there are a few things that you would address in this research paper. And you can choose any option, guys. I'm not going to be biased. Trust me, I'm not going to penalize you on which option you choose, although I just gave you my opinion. But if you write a research paper, I would be equally, as I said, there would not be any bias if you write the paper as well. So you have got both of them. For the assignment one, the idea is that you explore the basic and yet most powerful distributed data store Hadoop that can implement parallel process frameworks that you already know. And the objective is to kind of gain a basic understanding of Hadoop, how you kind of, navigate through Hadoop clusters and how easy or it is to kind of navigate through that. What is a MapReduce program? How would you run a MapReduce program? Write a simple, run a simple pig script, right? What is Hive, and can kind of sort of use Hive as well. So just try it out, guys. Honestly, give it a shot, right? And or maybe if you want to do both, right? Go ahead, and then you can submit one. So and as I said, you'll find that doing 1A, this exercise could be a very simple, easy exercise that you can get done in less than a couple of hours, right? But okay, but I'll leave it to you as to what comes in easier for you. Assignment 1B, well, you have a bunch of independent research questions or research-based questions that you would have to answer, and of course, using the whole format, 1.5 lines, any research paper that you would have written in the past, you will have to go through the APA formatting and all that stuff. But yes, so that's another option that you have. And the rubric, I really don't have to go in more details about this rubric. But yeah, it's every section of assignment 1A is going to be giving you equal points. I think it's mostly 10 points that you have, except for the first part, but most of it is getting you 10 to 15 or anywhere between 5 to 15 points for every step that you would perform within this particular exercise. So every step has got some points there, and it's very important that you go through each step, that you answer the questions, submit the document with your responses or whatever has been requested for. It could be a screenshot, it could be just a number, whatever has been asked for, you need to provide it and then submit it, right? Otherwise, you're just submitting it without those responses, or half, or not completing that document is not going to fetch you full points there. Okay. Same thing for your research paper. There are some questions that have been asked and that you've been asked to research on and provide your responses. So each of those sections or questions are going to be important. They have some points. And so if you skip any of those questions or those sections, you're not going to get full points, right? So you're going to miss out on that points completely. So make sure that you're addressing the assignments and the research questions or this or the 1B assignment completely, right? Even if you're writing a research paper. So that's pretty much what I wanted to cover during today's webinar. I hope this was helpful, but I'm open for any questions that you may have for assignment 1. Any questions on assignment 1? Are you guys okay? Have you gone through it, or you have not seen that so far? But if there is anything, we can definitely touch base on today.
I don't have any questions.
Okay.
I have looked over assignment 1A. I think that's the one that I'm going to complete. And I saw that I think Mary talked about it,
Yes.
the instructor questions, and said she had some difficulty, but was able to sort it
Yeah,
out.
she was able to finish that. Yes, she was able to do that. And that's why I said, you can take a lot of confidence from the fact that even despite the fact that she stumbled initially, she was able to complete it and get it done. So yeah, it's very interesting. And once again, not rocket science. So do not get discouraged by anything that you may stumble on. And if you do, please create a ticket right away, and let it go through Yelena. You can write an email to her, you can copy me, get the help you need. So please get started. If you have not got started yet, please get started right away. Unless you're writing a research paper. If you made up the mind to write a research paper, fine, I get it. Maybe when you would, what time you would need to complete the research paper. But if you're doing the technical 1A part, get started right away. You may get it done earlier too, right? But if you're stuck or you stumble anywhere, then Yelena and I can help you with and get you past through that step if you're having any difficulties. Okay,
Okay, great. Thank you so much.
welcome. Brian, you good with the assignment too?
I'm good. I've reviewed it and I'm going to do 1A as well.
Excellent, guys. All righty. So if not any general questions, besides, not just assignment, anything else you guys want to bring up? Okay, well, silence is golden. If not, we can call it a wrap. Thank you, guys. Have a wonderful rest of your evening, and I'll look forward to your submissions pretty soon. Okay, take care, and we'll meet again in a couple of weeks' time. Bye-bye.
Thank you.